Howdy, howdy, howdy. So today we're going to talk about the fact that the long division algorithm for dividing two integers, or it can be adapted to dividing decimal numbers, but it all comes down to how you divide integers. We're going to discuss how that algorithm comes from what's called the measurement view of division. So first of all, let's review what the measurement view of division is. If you're going to view a division problem, or expression I should say, x divided by y, which in long division would be written like this. In fractional notation, it looks like this. So viewing that division as the answer to the question of how many measures of y are in x is called the measurement view. It's equivalent to the repeated subtraction view of division. So in other words, asking how many measures of x are in y is the same as asking how many times can you subtract how many times can you subtract y from x. So long division is based on this view, and you might have realized that by remembering that long division involves subtraction, right? And here's subtraction here. It's a little bit more efficient, though, than just doing a straight-up repeated subtraction. Okay, so let's use an example. We'll do one without a remainder first. Okay, so let's say we want to calculate 578 divided by 34. Okay. So if we were to just do straight up measurement view, subtraction view, with no shortcuts, no attempt at efficiency, we would just count how many 34s are in 578, or in other words, subtract 34 from 578, however many times we need to get down to 0. That's going to take a little bit of time. Okay, we would have 578 minus 34 gives you 544, and then you would take 544 and subtract 34, you get 510, and so on. Now you would end up doing that 17 times. Okay, I know this because I've already calculated it. But if you wanted to calculate this way, you would have to continue 17 times, and that takes a while. So the way long division is actually working, when you put 578, 578 here, and then 34 here, okay? A lot of times people explain this by just saying, how many times does 34 go into 5? And you say 0 times. How many times does 34 go into 57? And then you'd say, in this case, 1 time, and so on. But I want to do this in more accurately using the measurement view, and noting that we're not talking about 5 or 57, we're talking about 500 or 57 tens, okay, or 570. Okay, so we're going to ask ourselves, how many measures of 34 are in 500? And so the answer to this question actually is something other than 0. When you just say how many measures of 34 are in 5, the answer is 0. But in 500, you can actually fit a bunch. Okay? In fact, we can fit at least 10 of them. Okay. Now, after that, we're going to not be able to fit in another 10. Okay, we can see that. Even if we take 578 instead of 500, and get 238, 238 is less than 340. So that means that's the maximum number of 10s we can fit in, 1 10. Okay, so that means we only have a 1 in the tens place. Okay, so we can see how many more are left. Okay, we would then say, okay, well, there's 238, and 238 now is the number we're trying to fit 34s in. So how many measures of 34 are in 238? Okay, well, it's definitely less than 10, and so what I like to do is I like to pick an easy number to start with. I'm going to pick 5. 34 times 5, well, that's the same thing as 34 times 10, and then divide that by 2, because 5 is 10 divided by 2. And so that's going to be 340 divided by 2, which is 170. You can do this calculation however you want, using the standard algorithm or whatever, it doesn't matter. Okay, so we can definitely fit 5, but we can fit more, right? If you're not sure on this, you can just find out. Take the 238 minus the 5 copies or 5 measures of 34, and we have 68 left. And 68 is greater than 34, so we can fit more 34s in there. So in particular, we can fit, if we take simply one more 34, okay, then we would get exactly 34 left, and so we see, sure enough, there is another 34 left in there. And so putting this all together, right, we had the 5 here, the 1 here, and the 1 here. We can say there are 7 copies of 34 are in 238. And so that's all we're going to fit, so we can go ahead and put this 7 in the ones place here. Okay, so that's thinking about it in terms of measures, but that's not long division, right? You didn't see long division has a bunch of stuff in here. Where is that? Okay, well, let's see where that comes into play in comparison to our work over here. So let's delete that. Okay, so you would ask yourself, okay, 34 goes into 5 no times. Well, that's the same as saying there are not 100 copies of 34 in there, so there's nothing here. Usually people just leave it blank, so I'm going to get rid of that 0, but you can also write that in. And then, okay, well, how many times does 34 go into 57? That's essentially asking how many tens of 34 will fit in to this whole number here. And we already know 110 fits, so we have a 1 here. And 110 of 34 is 1 times 34 with a 0 at the end, right? So we get 34, and there's a 0 here, okay? People often don't write this. I am going to write it, but I'll write it in a different color to emphasize that people typically do not write this, okay? Okay, so continuing. From there, we find out, well, how many more 34s can we fit? And to find that out, we subtract. Okay, so what is really going on here is we are subtracting 10 copies of 34 all at once. So we're doing the first 10 copies of this subtraction we were talking about earlier all at once. And we are ending up with an 8 here, a 3 here, and a 2 here. Often people talk about just bringing down the 8. I don't like saying bring down the 8 because that's just a procedure, that's just a movement. What's really happening is you're subtracting 0 from 8. Okay, and then we ask, well, how many times does 34 go into 238? That's it. Just asking how many measures of 34 are in 238. Okay, and then you would do some scratch work off to the side and find that 7 will work. Different people keep track of their notes in different ways, so you could have maybe done things exactly as I did over here. Try 5 and then subtract off another 34 and then see that there's exactly 34 left. Doesn't matter. The point is through your scratch work you would find that 7 times 34 is exactly 238. And then when you subtract and you get that 0, that's what tells you to stop. Just like over here, having these two match exactly is what told us to stop. And that matching exactly is the fact that you're subtracting something from itself. And so that gives us the answer of 578 divided by 34 equals 17. Okay, and that is it. I hope this helped you see a little bit of connection between the procedure of long division and the concept of the measurement view of division.